you sort of think about all the categories of different professional services or different, specific domains, I think they're going to be models that are good at all of them. And I think that sort of, right now, LLMs, pre-trained on the internet and aligned on sort of general problem solving skills. I think that the next layer is then getting into solving every single domain really in society.
Thank you, Adam, so much for joining us today. First, let's just tell us about your prior work experiences, why you chose those positions, and what you're most proud of, and how they led to your current work.
Yeah, sure. So I studied computer science at the University of Tennessee, and while I was there, I did research at Oak Ridge National Laboratory for the Remote Data Analysis and Visualization Group. So we sort of did the post-processing that came out of the supercomputer group there at Oak Ridge. Immediately after school, I was fortunate enough to be introduced to some co-founders, and we built an application that did natural language understanding of news. And so that was, pre kind of word dev, like really, it was much more like bag of words, term frequency, and first document frequency kind of similarity in between news items. And we built a mobile application that sort of was a news aggregator. This is like in the very shortly after Google Reader kind of days. And so was really interested in sort of understanding content, the kind of intersection of machines and news. So I started school initially as a journalism major and then transitioned into computer science. And so that sort of like combination of like how people get information and what information means has always been really interesting to me. After that, continued kind of in startup space, did some work for a kind of gig economy company called Bellhops, where I was the CTO and really built the entire team that thought about labor and capacity. And that was sort of my first brush with sort of workforce management and the way that technology can impact the kind of work that we do and really the future of labor as we digitize further. And so that was a really interesting kind of exposure to other consumer technology companies as well as two-sided marketplaces, and I really enjoyed that exposure. And then did some other kind of startup things, and then ended up at Meta for a little while, where I also worked on the news team, and so got to continue to kind of flex some of that natural language background as it related to news. Then from there, I was contacted by our CTO here at Invisible, who I'd worked with at a previous company and really enjoyed the collegial nature of the engineering teams that he set up. And so where I work now, Invisible, is a company that sort of combines three things. We do business process consulting, so basically understanding really large enterprises, the kinds of business processes that they operate on. We have a globally distributed workforce of thousands of people, and so that really matched with my background in terms of understanding labor and capacity and how that kind of fits into the equation. And then we also we do automation and AI enablement. And so what that looks like for us is sort of a combination of understanding a business process for an enterprise, whether that might be a document workflow for a bank or sort of a any of the myriad of different kind of relatively manual processes that insurance or healthcare kind of companies need to work through, and we solve those problems for them with a combination of our human workforce, sort of traditional automation solutions, as well as AI models. And now that AI models are becoming a lot more powerful, we're seeing that intersection and combination of things is really sticking in ways that are really exciting. And so it gives me an exposure pretty broadly across industries for different business problems. And we get to play with models that are doing really exciting things. And so that's kind of my gig.
That's you mentioned your experience in news. That was very similar, at least interest to me. So I was focused on multimodal analysis using deep learning, and one of my research projects were finding cross-cultural differences between, let's say, how a news station in India versus the United States might cover COVID, and using basically like word embeddings and vision embeddings, finding a shared space for that, and then using that to find sort of similar parts or portions of a news coverage. Like, curious to hear about, when you were working on news events, like what were some like really interesting problems that you're working on or solving, and some key lessons you got from that experience?
Yeah, so this was several years ago, and so this is pre even then was like before Word Devec sort of came out, and so we were primarily we were doing named entity recognition across items, and then sort of understanding the frequencies of those named entities, and as well as their prominence, and so effectively building matrices and databases of here is a particular article from a different source, and then monitoring user behavior in order to understand what is the kind of news that this person reads, and then are there other news sources that publish things that are related to that, or are there different sort of combinations of entities that we start to see patterns within.
Yeah, and so I think this is also interesting. This idea of we had like problems like named entity recognition and NLP that I think were more important in data pipelines prior to a lot of the large language model advances. So they're so important. But I think I remember when BERT came out, like the biggest thing I was using it for were named entity recognition, sort of financial application pipelines, healthcare pipelines. Like these kind of tradition, like how do you think about using these new technologies like large language models in some of these more classical data pipelines, like or data more classical issues or problems like named entity recognition? Like, do you think those types of traditional ways of solving problems are still relevant just with new issues, or is this an entirely new data pipeline that's coming through?
Yeah, I mean, so at Invisible, we think about everything from the end user experience first. And so we have a background, with our global workforce. We've been around for about 8 years. And so a lot of times we were taking on problems that companies would traditionally outsource and thinking about how to decompose those problems into smaller and smaller pieces. And so we've built a platform that effectively models a business process as a directed graph, similar to like the way you would think about like an Airflow job or something like that. And so we have a no-code platform internally that we've developed where we sit down with a business stakeholder and we say, describe this process for us. And we sort of sketch out, here are the individual steps. These are sort of the conditions. And we try to back into, what is this business process and what are kind of the decision points across that. And 5 years ago, a lot of times that would be us decomposing that business process into individual steps that could be accomplished by a human from our workforce. And so we've built a workforce management and kind of skills matrix to be able to understand across our workforce, if this is something where we're doing medical transcription, this part of the process needs to go to the working group that has medical transcription experience or certification or whatever the appropriate kind of skill would be. And so now what we're seeing is, because we're already sort of built into the DNA of the company, is this idea of being able to decompose problems into those directed graphs of steps. We're really attuned to also, if we can make those smaller and smaller pieces, then they become things that are really easily digestible by the model. And so we really try to build a framework and a foundation that's based on that understanding of the underlying process that's going to be executed, and then look for opportunities where a model might be a good fit, or you might be able to have oversight of a human workforce from outputs that are coming out of a model. And so we're really in a consultative kind of engagement in a lot of these interactions with our clients.
Got it. It's funny. For my research at Stanford, for large language models, we use directed acyclic graphs to explain how our data pipelines work as well. And it's funny because when you're in algorithms class, you're kind of like, why are all these computer scientists so obsessed with these graphs and they have all these algorithms just to traverse them, and you have to memorize them, and it's like so annoying. And then you get in the real world, it's like, oh, like that was why. It's because like almost every workflow, almost every problem can be solved if you just convert it into a graph problem.
Yeah, absolutely. And so like, I mean, just to kind of add a little bit more information about our platform overall, like because each one of those nodes can be reused across processes, we have thousands of different steps that we've created for this platform. And so in some cases, those steps might be an automation or an integration, like go fetch data from Salesforce and then load it into a process that's going to make a decision in terms of like routing it into other parts of that process. And again, like a lot of that is set up around the idea of being able to route it to people. But as models become more and more prevalent, we're vendor agnostic across any commercially available model. And so we've built up a library of different models that could be used. And then we think about this more as a configuration problem of designing a process that might use models at different stages of that, rather than sort of solving an end-to-end problem just with a model. We think about the interplay of models with the data problem that our customers bring to us. And since we're used to doing quality assurance on top of human work, we're also really attuned to sort of thinking about, is the data that's coming out of this process actually meeting our customers' expectation? And we have frameworks for how we think about evaluating that look a lot more like management practices than maybe things that would happen in a pure data science kind of problem space.
Got it. So Yes, definitely want to dive into your work at Invisible Technologies. But first, let's take a step back. We kind of briefly went over your background, and we start every event from our 200-person summits to 20-person discussion group with an icebreaker, just to get to know people on a personal level. So notice, I think you mentioned some experience in being a private pilot, I guess, or just how does, from your perspective, how does being a private pilot influence or reflect how your approach to technology development or team management? Maybe it's just something you do for fun and you don't think about the crossovers at all, but would be curious to hear a little bit about your passion there.
Yeah, I mean, so I love flying, and I really enjoyed it as a new activity. I learned during COVID, and so it was a great kind of way to get out of being really cooped up during that time. But I think doing things well, that are fast paced and that require a high degree of safety. I think it was a really interesting kind of concept to think through. So I really enjoyed kind of trying to think through the FAA produces tons of materials that tell you about what's going on in an airport, what are the practices that you need to follow whenever you come to this airport, what are the rules and regulations there, and kind of thinking through there are tens of thousands of planes in the sky at any point in time, and they need to get to places in bad weather. They need to do so safely, and we have a great track record in the U.S. For being able to do that. And so thinking about checklists and processes and kind of like what does good look like in terms of doing something the same way over and over again. And so I kind of use that metaphor when we talk about our software development lifecycle within the engineering team here at Invisible. So like I talk about, you go in to land a plane and you do the same actions over and over again. Like there's a very specific speed that you need to be at. There's a very specific configuration that the plane needs to be in. And if you do those to the point that that muscle memory, it really reduces your cognitive overhead, and you also you touch down at the same spot every single time. And so I think that kind of understanding of thinking about rigorous process, I think prior to that, having checklists and having sort of templates for things felt very bureaucratic, from somebody coming from a startup background. And so I think that for me, it taught me a lot about the value of structure and the value of sort of setting up processes and templates for people to be able to follow. Obviously there's a difference between trying to land a plane and trying to, ship a new feature, but I think that perspective was really interesting to me.
So this concept of, maybe you've heard of the book Checklist Manifesto by Tilgoan, and so that took the world by storm. And at first when I heard that book, I was like, what's the big deal? It seems like this person is just talking about creating a checklist. I do that all the time, but I think it's the philosophy behind it of when you're doing something very risky or has potential downsides, a lot of people who take those risks, it's not that they are oblivious to those risks or they don't feel the fear from those risks. It's that they know that if they create a rigorous and sort of detailed checklist of things to account for, that you can actually manage that downside in a way that makes it exponentially safer to do those actions and to manage kind of the downside. But curious, why even get into flying in the first place? What was you could have done a lot of things. You could have done cooking, you could have done sewing. Why this hobby?
Yeah, I mean, I don't know. I guess, why do things bring us joy? I think that it was just something that I'd had some exposure to. I had some friends that were glider pilots, and I always thought that was really cool. And so, it's just, I think that the idea of learning something that's challenging, that's outside of, what my day-to-day might be, I think was just really enjoyable. And I, also with that, I've been able to take some trips to places and that I think have been really fun, as well as, I've made some really great friends in the flying community. And I think that pilots, they love to talk about being pilots. And so it's a kind of a fun thing anytime that you bump into anybody that has that kind of background.
Wow. Yeah. Great. So switching gears here, moving into kind of discussion on AI, maybe to set the groundwork, can you share any success stories or use cases at Invisible, and what were the critical factors contributing to their success?
Yeah, so I mean, as I mentioned, we think about everything as a business process, and so we think about AI as a capability within those processes. And so one of the recent projects that we worked on was sort of a catalog management problem. So we were working with one of the largest brick and mortar retailers in the US, and they have a product catalog of 1.2 billion products. And that product information, comes in from tens of thousands of different vendors, but they need a really well-defined structure for those products. And so you could think a wristwatch that might be for sale in a brick and mortar store has 200 different attributes about it. And so taking a fact sheet that's a PDF from a vendor and getting that into your point of sale system in a way that helps you to run inventory, that helps you to sell online in addition to in store, and kind of understand the different qualities that a buyer might care about is really important for them to be able to get the sale. Like I think I've definitely experienced where you log into a website and you click the black box and think you're going to see a picture of a black t-shirt, and instead you see a white t-shirt. And so there's a lot that kind of goes into that merchandising experience of taking facts about different products and getting them into the format and structure that are appropriate. And when you're doing it the kind of scale that I was talking about for this retailer, it's a massive undertaking. And so that was a project that we took on actually several years ago that we had been running as a really mechanized sort of combination of automation as well as humans that were going through and reading and sort of doing data entry and data management tasks. And instead we started to see, hey, these large language models are really good at being able to pull different facts, but there are different challenges around certain product categories, either the data that was coming from different vendors that we had access to, or the specific attributes that we needed to pull out. There are different levels of success across those different attributes. And so we designed a process that did a combination of humans and AI in order to be able to solve that, and then came up with several different methods to be able to compare the outputs of those two different things in order to build our confidence across whether it was the data source or the vendor category, in order to then be able to replace a lot of that data entry task for categorical information or sort of dimension attributes or things like that across different products.
So maybe walk us through, we've outlined the problem. Maybe walk us through, how do you go about chunking that larger problem into like 3 key areas that need to be addressed? And then let's start from there, and then we'll talk about how, because as a technical leader, you're also thinking at a higher level of how to organize teams. So sure. let's first talk about the problem and how you break that down to the solution.
Yeah, absolutely. So I mean, with us, anytime that we're sitting down and talking to a customer, like we consult with them a lot in order to really try to understand like what are their business KPIs, like what is the problem that they're trying to solve, and we want to make sure that like we're not just doing something to spec, but we're actually going to provide value for them whenever we deliver data back to them. And as well as we want to understand what systems are we integrating with, like where are we pulling data from, sort of where is this data coming from when it gets to you, where is it going to go whenever it comes back from us, and really making sure that we understand how we fit into that process. And then from there, we have several different teams across the company that sort of then sit down with clients, whether it's their engineering team or their product teams, or even a lot of times their operations teams, to understand how is this currently being solved? Like, is this something where they're using an internal team? Is this something where the data is just not there at all? Is it a new initiative? And like really trying to build context so that way as we try to design a solution for them, we're able to, there's obviously contract negotiation that happens within any business in order to make sure that we understand the scope of work. And then from there, like we will build out the underlying business process that we've agreed to within our platforms, again, as a directed graph of individual steps. And a lot of times we'll start sort of at sketching at a high level. And for us, especially when we're establishing a new data set or something that doesn't exist yet, a lot of times we'll lean into sort of writing a standard operating procedure and then having a human workforce that works over it. And then that'll allow us to build an initial data set that we can then, start trying different techniques against, in terms of whether it's different models or different prompts or different sort of approaches in terms of trying to solve the creation of that. But a lot of times what we're doing is effectively trying to take something that is currently messy and complex that needs to be executed by a human, break it down into its component parts, and then be able to make each one of those parts something that a model or an automation or really any kind of machine learning process can take care of.
So Jeff Bezos, I think in the early days of Amazon, had this idea of making sure that every single piece of software you write is open to other teams to leverage. Mm-hmm. Kind of in that way opened up the ability for Amazon to build up the AWS business, which is now whatever, hundreds or if not $1 trillion business. Yeah. You're curious how you think about managing these dependencies, right? Because the quality of your results ultimately depends on the data that's coming in. And sometimes you don't, if you were an internal body, internal software engineer, you could maybe influence that other team of data that's coming in on how they structure the data, how they write the API. Like, curious how you think about working or resolving issues related to improving the quality of data, because I think that's the biggest barrier to organizations adopting AI. It's actually the quality of data and the way they structure the data beforehand, and working with legacy systems in order to do so.
Yeah, I mean, so like I'll be honest, like, you know, we have a point of view, and it's that a lot of those are going to involve, you know, large human workforces in order to be able to do that. Now, we also, you know, lean into the overall kind of data and schema design. So every one of our processes has associated sort of schemas that then, you know, do type checking, and we have the ability to then, you know, if data is coming in and is not matching an expectation overall, then we can work that into our process where, you know, there might then sort of be a branch that goes off for handling a particular exception in terms of the data. But, you know, each process is going to be a little bit different, you know, so again, that's why it's really important to understand what's kind of going on. I don't think that there's a silver bullet for, hey, all data problems, is there, you know, some way that we can filter? I think that it's, you know, creating assertions around what you expect to be there, and then sort of having, you know, exception handling around that, and whether that's like exception handling at the code level or exception handling at sort of the process design level. You know, you have to think about not just the happy path, but kind of the sad path whenever something doesn't go as expected. And the more that you can anchor around your data types or the distribution of that data, or sort of your expectation there, as well as provide monitoring and observability around, you know, the data that's flowing through the system. I think all of those are different techniques that you can kind of undergo in order to try to make sure that the data coming in matches your expectations. Then on the you know, flip side, kind of coming out, you know, we use a combination of different kind of quality assurance tools, whether that's us, again, sort of checking data types and distributions of things that are coming out of our processes, or if we do sort of sampled quality assurance of data that's coming out in order to make sure that it meets, you know, the expectations of our clients before we deliver it back to them.
Yeah, I mean, really, you can only control what's in your control, and so
Right.
you know, doing these measures, like doing quality assurance on the output, kind of type checking on the input, I think is really you know, the best way to manage the quality of data that's coming in and outflow of the data. I almost think like Invisible is almost like a kind of a black box within the workflow. So you maybe a company kind of has their own workflow, and you kind of piece in this piece of software you know, through that workflow. I mean, curious, are there philosophies on how Invisible should work within the entire tech stack? Are there opinions, or it's more of a case-by-case basis where it's really whatever their philosophies are, you kind of that influences the way you'll design a system, yeah, for the client?
Yeah, I mean, so like we definitely try to make sure, like I said, you know, that the KPIs of our customers kind of line up. We want to make sure that our incentives are aligned well, so that we can be a good partner with them. We've had, you know, several different kinds of engagements. So in some cases, you know, whenever we work with a lot of on-demand delivery companies, and so what that looks like, you know, encoding their menus and understanding all of the restaurants and pricing information that might be associated with that. And so for any one of those, you know, we want to sit down and understand, you know, where is this data going to go in your system? What are the KPIs that, you know, you and your team are trying to drive towards, and how can we design a process that, you know, is going to be cost effective for you and is also then going to be able to solve your problem. In other cases, like we also do a lot of work with companies that are building foundational models. So like we provide a lot of the human data behind some of the largest large language models. And so in those cases, we'll sit down with researchers and say, you know, what data is it that you need? You know, what are you trying to do with this model? And then we'll design a RLHF or supervised fine tuning kind of process with them and run that as a process. And most of the time, those processes aren't using any models. Those are entirely human. But again, I think that a lot of it is, for us, just very consultative in terms of trying to understand, you know, the problem there. But we work with, in some cases, research teams, in other cases, operations teams, and in other cases, engineering or product teams. And so it really just kind of depends on the client that we're working with.
Got it. So maybe going back to this case of the retailer, like how did this instance impact your approach to integrating AI in future projects? Were there kind of key lessons that you learned throughout the way?
Yeah, I mean, so it was definitely for us, like we had to up our game in terms of there was a ton of scale in terms of the number of requests that we were making. You know, at that point, I think we hit plenty of API limits, and so better understanding like how many tokens we're running through the system and being able to handle sort of parallel processing of a really large number of products. So that was one piece, and then also our team I think came up with some pretty interesting ways to compare. A lot of times we were doing both a human kind of driven workflow as well as an AI driven workflow, and so we ended up taking the outputs from both of them and turning them into embeddings and then comparing the distance in between them in order to kind of understand like how far away was the human answer from the model-driven answer. And then that allowed us to kind of build confidence across different categories or different data sources so that way we could understand, red, yellow, or green across, different kind of sections of that data set to understand, is this something that needs to go to our human workforce, or is this something that the model can fully take care of, as well as helped us to then investigate. We ran a lot of A/B tests across different prompts and sort of different amounts of context, and it's kind of an optimization problem within that, because if you're feeding a lot of context, and you're going to pay more for tokens, and so that's also sort of a cost benefit analysis of understanding what's the cost of having a human completely do this, what's the cost of like feeding in a ton of context all at once in terms of the accuracy of the answer that comes out, and then what might be other variations of this prompt that might include less context, but that might be cheaper in order to get the answer. And so like thinking about those trade-offs across the problem, I think, taught us a lot about then how we, go about optimizing and figuring out the exact fit of where models make sense in order to solve data problems.
You mentioned scale at the first part. This is a common question that we get a lot, in that, sure, the LLM may be able to service maybe a couple hundred people, and that's great. But for a lot of large organizations, if the LLM can't serve, tens of thousands, hundreds of thousands, millions of people, then it's not even worth the investment, because they may want to build those capabilities in-house, hire machine learning researchers and engineers, data scientists, data engineers. So you're curious, this problem of scale is actually a huge inhibitor to the deployment of AI in real companies. So how do you mentioned parallel compute? Can you give a little more detail on the algorithms, the techniques, the libraries? Just how do you address this issue?
Yeah, I mean, so we used Helicone in order to measure and kind of understand the number of tokens that we were using, as well as to keep an eye on cost. And then, I mean, there's sort of traditional, just notebooks and pandas to kind of understand, like what is the cost going to be, and make sure that, as we're doing this, that it's something that's still going to be economically viable for us in order to solve our customer's problem. And then from there, I mean, we also we're big users of LangChain as well as a part of that. And then also all of this is sort of we're implementing different steps in that larger kind of process orchestration engine that we have internally. And so we think about that, and there's built-in parallelism in the event execution of our internal tooling. And so that gets us really far in terms of being able to handle parallelism. We ended up having to implement some things around rate limiting for that. So like you still hit caps in some cases where it's like we can do inference in parallel, but then when we're working with a commercial vendor that has a global rate limit, you also kind of run into that. And so there were some cases where we were even having to sort of dial down how quickly we were processing all of these different products, because it was in the scale of millions. And so having to make sure that we also in some cases even had enough time to be able to process data at that volume was an interesting challenge for us.
If you're processing at such a scale, you have a lot of training data. Mm-hmm. You may have a lot of compute resources. Why not take a open source model, fine tune the model, maybe improve performance using a pipeline of different language models? Like why commit to using an API still? Is there a philosophy on when you should use some of these APIs versus just do the fine tuning of a model in house and keep that proprietary model that you can build upon as you have more customer data, and you can create a flywheel?
Yeah, I mean, I think that's something that we're certainly exploring more now. So I mean, at the point in time that we were working on this project, that was the way that we approached it. But we're certainly seeing also that cost benefit trade-off in terms of if we fine tune a model, then there's also ways that you can do it much more cheaply. And so thinking about, does it make more sense to up front and then get faster and cheaper inference, or does it make sense to sort of do more of a prompt engineering? And I see those as two sides of the same coin. Like, you can add a ton of context, you can do sort of like the retrieval augmented generation kind of approach to solving a problem, or you can fine tune the model and then a lot of times get better results. And so and we didn't in this case, but I think that's not because we're philosophically opposed to it, and we're seeing that kind of approach now as we jump into other client engagements.
Yeah. I'm curious, like, what type of performance in terms of accuracy did you demand? So when I was a machine learning engineer for a healthcare company, like that level, and let's say you're doing a screening process or diagnosis process, you sometimes want to err on the side of saying this person has a disease, because then they can be filtered and go to a real doctor to get checked up. Whereas, on a more consumer-facing app, accuracy and performance doesn't matter as much because there's not a sort of singular objective function. What type of accuracy, or how stringent your requirements were in this case? Like, how did that influence how you built the system? Because the reason why I'm asking is because if you're if you need really high accuracy, then you might want to use an API. Whereas if you're not as tolerant, like with our work at Stanford, you can piece together a data pipeline where you improve the retrieval, the prompts using a language model, and you use a retrieval model, and you use a fine-tuned model, and our tool can allow you to create a really great pipeline that may not perform just as well as the API, but you can be scrappy and create your data pipelines in such a way that you can lower your cost. You may not have as much accuracy, but that might be great for a lot of startups. So curious, like, what was your kind of threshold there for performance?
Yeah, I would say this one was a retail consumer problem space, and so sort of had the kinds of guardrails that you would expect for that kind of problem domain. So I think that certainly, like, if we were doing something in the life sciences, or whenever we work with our healthcare clients, the bar is a lot different, and there are then more checks and sort of more expense on a per unit basis. And so, like, I definitely think you're calling the right question, which is like, how accurate does this need to be, and then what are the protections that I'm going to put in place in order to make sure that it's right. In this case, certainly it's really important, economically for one of our clients in order to make sure that the data is as accurate as it possibly can be, but it's, not necessarily the same bar that you might have for a healthcare kind of use case.
Yeah, and I think the more we go into this realm, and the more AI is deployed, people are going to realize that you just make it as accurate as possible will not be the question that you'll optimize for all the time, particularly because of the discrepancy between the open source community and the closed source community. People, I think, are going to do the financial math on, do I really need that super accurate model if it's going to cost me 10x, sometimes 10x as much. So really interesting to get your thoughts there. So moving on, someone who's sort of deeply involved in the creation and support of tech solutions, like, how do you balance sort of cutting edge innovation with the ethical considerations of sort of data privacy and security? And the reason why I ask is because when I talk to my engineering friends, the biggest thing on people's mind is, how do we train more efficiently, right? How do we train where it doesn't cost people like $1 billion to train a model? When I ask my friends who are non-technical, it's data privacy. That's the only thing I ever hear about. And you're curious to get your thoughts on how you think about data privacy, and then conveying that to the customer, because oftentimes you're conveying those concepts to a customer who's non-technical and just wants to be assured that you're handling their data in the appropriate manner.
Yeah, I mean, so we start that with a framework of traditional kind of security oversight. So we're SOC 2, Type 2, and HIPAA compliant in terms of just like data at rest. And then from there, we lay out, again, because we work with clients in different industries and that have sort of different problem spaces, like, we want to make sure that we're agreeing to them exactly how we're going to use their data, as well as that we know where it's coming from, and that we're able to then make sure that we're still in compliance and we're following both our legal as well as our ethical requirements for any of the data that we're processing. We don't hold on to client data that passes through our system. So, like, we're not if we produce a data set or we solve a business problem for one of our clients, we're not using that to train our own data. And so by default, their data is their data. And so that, takes care of a lot of sort of the data privacy related concerns, because we're not sharing it in between clients. We're sort of pretty tightly compartmentalizing that. And by having that partition, and we don't run into that kind of space as much. Now we have talked to clients in regulated industries or financial services industries where they don't want to use OpenAI, or they don't want to use, a kind of commercially available hosted model. And in those cases, like we might then run Llama 2 or one of the sort of open source models within our infrastructure in order to make sure that their data is not passing to any third party. But a lot of times, again, when we sit down and design a process with them, we also walk them through like, hey, this is the data and this is where it's going to pass through. And we make sure that that's going to meet whatever their requirements are.
So then let's say you've set up the system that's complies with a lot of these kind of data privacy principles. You put that out into deployment. Like, how do you approach continuous improvement and refinement of AI in a production environment? And what strategies do you suggest for handling model updates and retraining? This comes from like a personal pain point for me, which is, was working, we once had this, the ML deployment was built integrated to software engineering. And so we couldn't sort of A/B test model endpoints, do live training so that the model updates with real-time customer data. But even if you get those systems set up, it's very hard to manage and do monitoring on that. Like, curious, like how you think about the right approach to improving in real time from customer experience, but at the same time, like being very careful that you can control the performance of that.
Yeah, I mean, so up until this point, we haven't done real-time or close to real-time fine-tuning or sort of retraining. A lot of times we're doing that more in batch at like a daily or weekly kind of level. And so with that said, I mean, because we are sort of sitting on top of a directed graph, we can redesign processes in order to make sense and kind of solve problems there. I think that again, individual clients are going to have KPIs around like what does data quality need to look like for them, and we've used various different systems, whether that's Datadog or some of the other commercially available kind of like observability and monitoring tools for metrics for anything that's passing through a model to understand how it's performing, and then that can sort of be a leading indicator for, hey, this is falling off or needs to be retrained, or otherwise needs to be improved, needs some other sort of level of oversight.
So that's really interesting, and I think the key kind of takeaway from that experience is, how do you both design a system that's efficient and effective that can also be communicated to the customer you're working with? And I think that's going to be a key issue, or sort of key challenge for a lot of people listening to this moving forward, because I think no one asks, how does Salesforce look like under the hood? Like, people just use Salesforce, they kind of click through. But I think oftentimes with AI solutions, people are more curious, like, what are you doing with my data? How are you doing kind of the inference part of this pipeline? So kind of shifting gears now to your experience. So we talked about Invisible, kind of problems you worked on. Like, curious, like, what advice do you have for teams who are just starting their journey for enterprise use cases? Because you've been a part of sort of starting companies. Like, curious to hear about how those roles were different from now. You may be deploying to sort of millions of customers, or how do you think about that, the shift in your roles?
Yeah, I mean, so I think certainly big company problems a lot of times, like, they're going to have either compliance standards or sort of overall like the procurement process is going to be a lot longer. I think you really have to make sure that you have an understanding of what are their pain points, how do they think about their buying process, the overall kind of customer success journey, and making sure that not only are you working through the way that they think about buying things and making sure that you check all of the boxes there. It gets more complicated in that way, but also that you continue to have internal champions that continue to use your services, and that's an opportunity for expansion in terms of continued growth and continued kind of usage. Like, that we've run into situations before where you're working with one team within a larger enterprise, and then somebody moves on, and are you still connected to the larger company? And so I think that kind of understanding their org chart internally and understanding like how they think about buying something and how the thing that you're building is going to fit into this much larger machine. I think it's a little bit easier whenever sold solutions into other startups because you're like, oh yeah, I know the CEO. Whenever you're, one branch in a huge structure, I think that it's a lot more complicated to kind of understand what's happening on your counterparty side.
Right, right. I think one of the key issues is that when you're a startup, you may not know how the larger enterprise is they function different from the way you are, right? It requires a little bit of empathy, and that there's a lot of counterparties. There's a lot of agreements that they reach between the different parties. You have product, you have engineering, you have security teams, and so having empathy for that I think, will be very important for any people listening to this that are building a startup in AI. Given your background in traditional software engineering groups and now moving to machine learning and AI, there's a lot of people trying to make that transition. I think there's a lot of things to carry over, and there's a lot of things that are different. Distributed systems and designing systems will always be integral to every single software-related system. But curious to hear how your strategies and your leadership strategies have changed moving from both worlds.
Yeah, I mean, so like I think that definitely like the people skills are transferable. Like within all of these organizations, like they're made up of individuals, and those individuals, you're going to have career goals. And so I think that a lot of the aspects that go into leadership in terms of, how do you take a big problem, break it into pieces, make it understandable, communicate that to the broader organizations. Definitely, leadership and management skills, I think, are a pretty evergreen thing, regardless of like whatever the latest in technology is. I also think that, a lot of the processes around sort of just traditional software development lifecycle of kind of understanding like how do we do discovery with a client, how do we identify what the problems are going to be, how do we prioritize things, and sort of some of the even product management kind of skill sets, are really valuable. Instead of writing code that might be deterministic, now we're sort of dealing with models, and it's much more of a probabilistic kind of outcome. And so I do think that that lack of determinism, I think, becomes an interesting challenge if you're used to, every time that I run the script, I get the exact same output. And now all of a sudden I'm talking in terms of statistics instead of, something that's more definitive. I think that definitely is different. I mean, also, I studied computer science myself. And so like I deal now with a lot more people that have PhDs in math. And so I think that there's definitely a steep learning curve whenever, computer science, definitely a transferable skill and something that you can grow into, but certainly, I think that they're working with anybody that's an expert in something more deeply than you might be as a leader, I think is an interesting challenge the first time that you do it, of, understanding how to set up a project plan with somebody, how to work through problem solving in a case where somebody else is a deeper expert in a field than you are. I think requires humility as well as like a curiosity in terms of continuing to learn and continue to kind of expand your understanding.
As you think about, you mentioned those interpersonal skills, is there kind of a rubric, let's say like 3 things that people who are looking to move into an engineering leadership role in an AI organization, are there kind of 3 things you think about as your kind of guiding principles for how to be a great engineering leader or manager?
Yeah, I mean, I don't know if there are 3, but I'll do my best. So, I think one thing that I always ask people whenever they're thinking about moving from sort of individual contributor work into management is, do you really want to be a manager? Or do you just want a promotion? So, I mean, I think like, first of all, you want to make sure that you're doing something for the right reasons. Like, I think a lot of times, like, management's just a different job. It's not actually a promotion. And so I think that like coming into that with eyes open for people that are transitioning, from, doing individual contributor work, like really making sure that, that you're making that change for the right reason. I think, one of the things overall, just clarity and communication. I think like, a lot of times my job is to continue to listen across the teams and then make sure that, especially in a remote environment, that everything that I hear is sort of being put into a structured format that can then be transferred out to people, and not taking for granted that everybody has context. So like I think a lot of times that my role is kind of megaphone of the organization. So being able to repeat the joke that I always tell my team is like, at the point in time that everybody tells me that they've heard this already, then I've started to break through in terms of making sure that. So I think that a lot of especially people that are experts in a particular field, they assume that people understand them when they don't. And they assume that people know what's going on when they don't. And so I think that sometimes, it's a transition in terms of both, making sure that you're really solid at communicating to people, that you're communicating across all the different channels that somebody, might take in. And I think that a lot of first-time managers that I work with, they are used to sort of thinking like, oh, well, I've said this once and everybody understands it now. And so instead sort of like thinking, my boss actually talks a lot about like, what's your stump speech? Like there's something that, like you're gonna continue to sort of re-communicate that message over and over again, and giving a team kind of a vision that they can rally behind. It feels really repetitive for people, I think, that are coming from non-management backgrounds or non-leadership backgrounds. It feels like something that you're repeating yourself a lot. And I'm gonna whiff on the third one. I think I don't know if I have a third rubric for you today.
So the idea of being an evangelizer, I think there's a Jeff Bezos quote saying that like his purpose in the organization is to repeatedly evangelize for Amazon's core mission as being a low-cost provider, et cetera, et cetera. Like the point is that why do people prefer sort of founder-led, or there's been a shift in recent years, probably the past 10 years in the technology ecosystem, why people love founder-led organizations, or at least a founder is kind of a part of that, and being a key voice is, I think, because they have that passion and joy of what the organization was at its birth, and they can kind of keep reiterating that. And I think that also applies for all aspects of leadership, and that actually has a tremendous amount of value. But you mentioned working with PhDs in mathematics, and there's been a really big discussion recently. Like, do you really need those core machine learning algorithm skill sets anymore if you can just hop on Hugging Face or use LangChain? Like, what is your perspective on a lot of young computer scientists these days? Like, what should they focus on in the ecosystem? Should they study probability, statistics, multivariable calculus, linear algebra, and then study machine learning, and then learn Hugging Face, or maybe there's some other route that you imagine?
I mean, I think it depends a lot on what somebody wants to do, and there's a lot of value creation across that entire spectrum. I mean, I think that there are going to be a lot of places where AI problems are actually going to be UI and UX problems, and design skills are going to be really important. I think that there are going to be other places where, if you have a deep understanding and empathy for what your end user needs, then product management skills are going to be really important. I think in the sort of applied space, there's going to be a huge opportunity for people that have a background in computer science and kind of the fundamentals of software engineering to be able to build systems where they're going to be able to be practitioners of models that they might not have a complete understanding. But like, that's not new. Like people use Linux every day that have never written a kernel themselves. And so I think that there's going to be a huge opportunity for people to then be able to find value creation in places where they might not have a really deep research background in terms of the ability to create these models. And then I also, I see more and more content that's popping up that's specific to, being able to better understand models and their capabilities. And so I think that there are also going to be non-traditional paths for people that maybe don't have a PhD in a STEM discipline to be able to, if they're interested and motivated, to be able to understand and continue to grow that skill set. I'm not advocating for how somebody should approach education, but I don't think that should be a blocker for anybody that finds it interesting and that is passionate about it.
Exactly. I mean, I think the key is, let's say you were in the kind of 1970s, or close to the dawn of the personal computer. Like, you didn't need to know exactly how Wozniak improved the personal computer to know maybe how to create a compiler or how to create the basic initial business applications on the personal computer. So I think the same will go for in the AI realm. There will be people who are very great at optimizing AI systems, just the way Wozniak was great at optimizing the motherboard or any other sort of components of a PC. Interesting want to kind of dive more into the one piece of advice you have. Now we've kind of talked about computer scientists, maybe moving to entrepreneurs, because as you have been on this entrepreneurial journey yourself, like, what advice do you have to those people, and especially harnessing AI for those means? Like, a lot of people are thinking about AI in that it benefits a lot of incumbents. So maybe moving, Oracle was really on premise and developed some sort of customer relationship management software, but then Salesforce really disrupted with fully committing to the cloud model. And there's all these other cases you can see where in the personal computer industry you saw this as well, in the semiconductor industry you saw this as well, where startups have some fundamental advantage over incumbents, which we may not see as clearly in the AI realm. Maybe you could talk to how people should think about starting their business in the AI space.
Yeah, I mean, I think overall, certainly the better that you kind of understand incumbents and where their weaknesses might be, I think that, that to your point about sort of the Oracle and Salesforce example, like there are going to be some places where companies that have access to a lot of data or have access to, armies of research teams, there are going to be things that they go after and that they have, structural advantages to be able to tackle. And so I think that thinking about, maybe a contrarian point of view around things that they're going to be less good at sort of allows you to compete in a place where, they're not going to have kind of built-in advantages. So I think that certainly helps. I mean, I also, I think a failure mode of like, this is an AI company. I think like, most companies, they solve problems for people, whether those people work at companies or whether those people are, in the consumer space. And so I think continuing to understand, like with the end user in mind, like what is the value that's going to be created by this thing? I sort of see a failure mode, and this was true, prior to kind of the explosion in AI, like engineers solving problems that engineers think are cool. And I think that a lot of times, like you need to really continue to develop an empathy for, the people that are going to use your software and how they're going to use it, and what it's going to be good for. And so be a solution to a problem, not a solution in search of a problem.
Right. And I think that's also why Silicon Valley is great at churning out infrastructure software companies, cybersecurity companies, because you can allow engineers to just say, hey, this is great for me. This is something I would want, and I'm going to build it for other people. And what I've seen, at least on the application side, it doesn't necessarily need to be in Silicon Valley, because as long as you, like, let's say there's a lot of great vertical software companies out there, like Aviva, there's a lot of accounting software that doesn't necessarily need to be in Silicon Valley, because as long as you, or for insurance business, you have Guidewire, you have Duck Creek, and the reason why these businesses don't necessarily need to be in Silicon Valley is because the key insight is solving the customer's pain point. And if you can do that with AI or Web3 or cloud computing, whatever is underneath the hood, the core problem doesn't change. It's solve people's challenges in a better way. So definitely agree with that point. And I guess the key thing is, for a lot of people, is that they're in search for those key things that AI allows people to do that you can't do with software 2.0 or some other prior techniques in AI. And so I think that's what a lot of people are in the hunt for. So wrapping up, final question that we ask every time is, what is the AI industry going to look like 1 year from now? Now, I know you can't answer this exactly, but it helps people what they work on, what companies they build, the way to design their software architecture. So it still is a critical question to at least have some thesis around, because it influences what you build right now.
Yeah, I mean, I think that like we're seeing an explosion in terms of purpose-built models that are solving, specific kind of business problems. And so one of the things that I've been thinking a lot about is, if you sort of think about all the categories of different professional services or different, specific domains, I think they're going to be models that are good at all of them. And I think that sort of, right now, LLMs, pre-trained on the internet and aligned on sort of general problem-solving skills. I think that the next layer is then getting into solving every single domain, really in society. And so I think that you'll see, continued growth, whether that's, I've seen plenty of startups in the legal space. I've seen, obviously tons of them that are in healthcare. And I think that you're just going to see that across all of the industries. And so it's going to be really interesting. People that have access to that data, or, that are well positioned in terms of like software teams that might be building solutions for those, I think that they're going to be really fascinating applications that solve more and more niche problems. And you just sort of see things kind of start to take over the long tail of problem space. Whereas, we had a huge explosion in kind of general purpose, and now the fine-tuned or more domain specific or subject matter specific models, I think are really going to take hold over the next 12 months.
Yeah, I think also OpenAI developed ChatGPT and the GPT models, and so there is still room. If the incumbent would always win, then ChatGPT would come from Google or Facebook, who had the best researchers, the best engineers. And so it's just going to be, as we kind of talk through today, is finding those little slivers of opportunity in AI. And I think hopefully people will find that. So with that, all right, everyone, thank you for listening. That's our interview with Adam from Invisible Technologies. Collective Nation, as we wrap up another episode, I want to express my gratitude to you and to Adam, our guest, and our curious and passionate listeners. Today's discussion has once again illuminated the field of AI, offering us a rare glimpse into someone who's really shaping the field. As always, we are building this podcast with the GenAI Collective community, so please reach out with any feedback or suggestions. If you'd like to be a guest on the Collective Intelligence Community Podcast, please get in touch with us. Details for doing so will be in the show notes. If you enjoyed the episode and would like to support the Collective Podcast, please leave a review or comment on your favorite podcast platform. Thank you for being a part of this journey. Until next time, keep exploring, keep questioning.